Algebra 1 students, welcome to your 1.6 notes, multiplying and dividing real numbers. One of your favorite parts of notes like this every day should be the ability to learn awesome music from Mr. Hale. Today's group is Family Force 5. They're pretty amazing. So they like to crank it like a chainsaw. Today we're going to multiply and divide real numbers, and we're going to do it well. So we're going to be cool just like them. So here we go. The key concepts. If you multiply or divide, I'm going to give you the synopsis, the summary of these two all in one. If you multiply or divide two positive numbers, you get a positive result. If you multiply or divide two negative numbers, again, positive result. When it changes is if one number is positive and one is negative, and in that case you will of course get a negative. So we're going to do a little work with our brains and with the great knowledge that we have of multiplication tables and things of that nature. So let's do this. Find the product. 5 times negative 11. Well, I see that I have a positive number and a negative number, so I know when I multiply them I'm going to get a negative, and the negative I'm going to get is 55. And that just comes because 5 times 11 is of course 55. All right, on number 2, this time notice negative number here, two negatives. When you multiply two negatives, that gives us a positive. Negative 7 times negative 8 is the same as 7 times 8, and we all know that that is 56. Now, if you had to get your calculator out to test that one, go ahead and turn that calculator off and nicely put it away in your storage spot, because you won't need it till the next chapter, and you won't need it on number 3 or number 4 either. So go ahead and pause the video and do 3 and 4, then compare your answers to mine. All right, welcome back. Here are my results on 3 and 4. Hopefully they match yours. Some of you may be like, holy cow, Hale, 13 times 6. Have to do that in our heads. Think about it this way. What's 10 times 6? You guys know that. That's 60, right? And you also know 3 times 6 would be 18. And if you add 60 and 18, you get 78. You can do that mentally. All right? You can. You can. Don't even tell me that. I know you can. All right, so here we go. Number 5, we're going to find the quotient. So this time we're same kind of problem. We're just doing division instead of multiplication. No big deal for us. 63 divided by negative 9. I see a positive number divided by a negative number. And the result then, of course, would be negative. 63 divided by 9 is 7. So 63 divided by negative 9 would be negative 7. Number 6, negative 121 divided by 11. Well, again, we have one number's negative, the other's positive, so this is again going to give us a negative result. And 121 divided by 11 is 11, so our result there would be negative 11. Again, go ahead and pause the video. Do 7 and 8 on your own, and then I'll work on 9 through 12 with you after that. All right, welcome back. Hopefully you got the same results I did. On number 7, we of course got 2. 16 divided by 8 is 2, so negative 16 divided by negative 8 would also give us a positive 2. And then on number 8, 144 divided by negative 12 gives us negative 12. It's probably worth pointing out here that on both numbers 6 and number 8, I gave you examples of perfect square situations. So like 11 times 11 is 121. 12 times 12 is 144. That kind of leads into what we're doing on the next set of problems of simplifying radical expressions. So this is still using our skills in multiplication, division, but it's just in terms of square roots instead of just simply multiply or divide. So here we go, simplify the expression. Now I know not a lot of you have the square root of 900 memorized probably, but I do think you know the square root of 9, which is 3, right? And so we got 2 extra zeros on the end. Folks, if you think about place value, really all you need to do here is 30 times 30. 30 times 30 is 900, so the square root of 900 is exactly 30. All right, number 10, we've got a negative sign out in front of our square root symbol, and then we have the square root of 16. I'm just going to leave the negative there. The square root of 16, we know, is 4. Number 11, again, we have a negative out front. We're not going to worry about that too much yet. But let's talk about how do we do 0.36. Okay, so there are a couple ways you could think about it. If you read this number the way that your teachers when you were younger taught you to read it, you might think of that number. You might read it as 36 hundredths instead of reading it as 0.36. Okay, and if you know the square root of 36 is 6 and the square root of 100 is 10, then you can handle that problem. Although the one thing that we probably should point out would be if you're doing it in fraction form, you would want to simplify it. But since this starts as a decimal, I'm actually going to go ahead and change it back to a decimal, negative 0.6. Now it is possible too that some of you may never go to the fractional form. You might look at this and say, yeah, 36 is a perfect square, so if I do 0.6 times 0.6, that'll give me 0.36, and then I still have that negative out in front. All right, so there are a few ways to handle that. None of them involve a calculator. Not for us. We're better than that. All right, plus or minus the square root of 9 over 49. I'm going to think of this as basically two separate problems. The numerator is the square root of 9. The denominator is the square root of 49. Square root of 9 we know to be 3. Square root of 49 we know is 7. And then we have that plus or minus still out front. That means we're considering both the negative and positive possibilities. All right, one last topic we want to look at, and that is division of fractions. And the concept is a bigger concept. I'm going to actually use a little of this space over here to kind of write this out. And it looks something like this. And I'm going to use variables, but if you have a over b divided by c over d, that's the same as writing a over b times, and then you have to reciprocate the second term, so d over c. So we change division to multiplication, and then we reciprocate, or find the reciprocal of, the second fraction. So we're going to use this concept right here to evaluate these three examples. So let's start with number 13. The instructions say use the given values of x and y to evaluate x over y, or x divided by y. So on 13 we're going to have 4/5 divided by negative 3/5, and I'm just simply going to rewrite it like this. I'm going to say that's 4/5 times the reciprocal, so that would be negative 5/3, and then some of you are probably noticing right away, like, hey, we got these 5s here, they're going to cancel out, and I'm left with negative 4/3 is the result. Dividing by fractions, it's kind of hard concept for us to think about in our brains because we don't have a lot of real life applications necessarily, but it's really not too complex when you actually get down to it. Like, what do you have to do? So let's try another one. Number 14, x is negative 3/2, so that's in my numerator, and then my denominator is negative 6/7. Now notice here we have a negative divided by a negative. That's going to give us a positive, so I'm basically just going to get rid of the negative symbols right here, and I'm going to do 3/2 times 7 over 6. Notice that I took the reciprocal of the denominator and changed it to multiplication, and at the same time I went ahead and just lost the negatives. Now another thing some of you might do now, some of you might do it later, I prefer to do it now, is I see that I have a 3 here and a 6 here. I'm going to change that 3 to a 1, and I'm going to change the 6 to a 2. Okay, now if you don't do it here, you could simplify later on, and we'll get 7/4. Okay, let's say that you don't like simplifying before you multiply. Okay, so I'll just give the little scenario here. Your answer would have been 21 over 12, right? 3 times 7, 2 times 6. And when you think about it, 21/12, so if I divide 21 by 3, that gives me 7. And divide 12 by 3, that gives me 4. So I get the same answer, 21/12, so I'm just simplifying later instead of earlier. Totally your preference, okay? All right, for one final time, why don't you pause the video, do number 15, then compare your work to mine. All right, welcome back. You can see my work on number 15. Notice that I went ahead and got rid of the negative symbols right away. I changed the negative 2/5 to positive just because we had a negative divided by a negative. I knew those negatives were essentially going to leave me with a positive, so there's no reason to worry about them. And then I went ahead, this time I didn't simplify, I just went ahead and multiplied. 2 times 5 is 10, 5 times 6 is 30, And I knew that 10 divided by 30, well, 10 goes evenly into both, so 10/30ths is exactly the same as 1/3. All right, folks, that concludes our 1.6 notes. Come to class tomorrow, ready to work hard, and have a great day.